I am very well acquainted too with matters mathematical. I understand equations both the simple and quadratical. About polynomial theorem I am teeming with a lot of news. With many cheerful facts about the square of the hypotenuse.
Now, if a line is sloping, as this one is, this one is, if it's going up 3, it's going back 2. It's a minus slope, it's going downhill. So if it's going up 3, it's going back 2. 3 up and back 2. That's the way the line is going. 3 up and back 2, right? Or 3 down and across 2. Either way, it's a downward slope, it's a minus slope. Now the perpendicular, if this slope is going up 3 and back 2, the perpendicular will do the opposite. The perpendicular will always do the opposite. It will be uphill. It will be uphill and it will do the opposite. It will go across 3 and up 2. That's what the perpendicular will do. To be perpendicular, it will do the opposite. So if we know the slope is minus 3 over 2, the perpendicular slope is plus 2 over 3. So K is perpendicular. It's perpendicular to L. So that's the slope of K. Slope of K. Perpendicular slope of K is 2 over 3. Now we know the slope is 2 over 3, and the point, we're told, is 7, 3. So the equation of K is y minus 3. Y minus 3 is the slope times x minus 7. That is the equation of K. If you can zoom in on it, here it is. Here's where it's turned on your, there will be L, that's L. And coming from 7, 3, passing through it is K. That's the way it will turn up on your graph paper. Now you were asked, find the equation of K and the point of intersection of K. And if you do nothing more than draw it out, you will see that the point of intersection is going to be minus 2, minus 3. If you draw it out, you'll see that the slope here, well, we won't worry about the slope. The point of intersection is minus 2, minus 3. And at least if you can't get it any other way, draw it out. But the way they want you to do it algebraically is tidy up this equation. Get rid of that 2/3. They don't like that. They like an x, a y, a number, a naught. So we'll multiply that by 3 and that by 2. That will give me 3y minus 9 will be equal to 2x minus 14. I multiply the y minus 3 by 3 and the x minus 7 by 2. And bringing the y, I'll have 2x minus 3y. I'm bringing those over there. I'll have minus 3y and plus 9. Plus 9 and minus 14 will give me minus 5 equals 0. That's K. And L is 3x plus, there's L up there. Now, we have to find where those two lines meet. And that's a simultaneous equation. 3x plus 2y equals minus 12, and 2x minus 3y equals 5. To get the same number between them, let's get rid of, say, the x's. I'll multiply this line by 2, all of this by 2 to give me 6x, and this by 3 to give me 6x. Then I'll have 6x plus 4y equals minus 24, and 6x minus 9y equals 15. But I want a minus 6x. I'm going to change all these signs. In other words, I multiply that by minus 3. I've got 0. Here I'm going to get 13y equals minus 39. Y equals minus 3. And if y equals minus 3, 3x, and from this line here, 3x minus 2 minus 3's equal minus 12. 3x minus 6 equals minus 12. 3x equals minus 12 plus 6. 3x equals minus 6. X equals minus 2. And they meet at the point minus 2, minus 3, as we saw as we verified in the diagram. So that is the 2003 coordinate geometry question, number 2, paper 2. And we're going to do now the 2002 coordinate geometry question.
I am very good at integral and differential calculus.